A peculiar die has the following properties. On any roll on any roll, the probability of rolling either a 6, a 5, or a 4 is 1/2, just as it is with an ordinary die. Moreover, the probability of rolling either a 4, a 3, or a 2 is again 1/2. However, the probability of rolling a 4 is 3/16, not 1/6, as one would expect of an ordinary fair die. Of course, we know that a die has 6 faces. Therefore, the probability of any one of those should be 1/6 for one number out of 6 possibilities. But this is a very unusual die. They call it a curious die. Well, it's not something that you would ever encounter. However, it does force you to really think about some probabilities. So now, what is the probability of rolling a 1, a 3, or a 2? And then what is the probability of rolling just a 1? Well, we know the probability of some groupings of these numbers, but we want to kind of change those groupings around. So for part A, the key to this problem is the selection of the numbers. All versions of this problem have some similar number relationships. They specifically choose numbers so that a few things work. So go into it realizing that these problems are set up to test you on a few topics. Okay? Your given information is that the probability of a 6, a 5, or a 4 is 1/2. The probability of 4, 3, or 2 is 1/2. And the probability of a 4 is 3/16. So these are our 3 bits of given information. And they come from the problem right up here. Okay? So I'm just going to take a pen. And so 6, why am I not drawing? 6, 5, or 4, there it is. Oh, this is doing that. My pen is not drawing where I expect it to, so I'm not going to draw. Oh well, I have a random line on my screen now. The probability are given here. Now, in part A, you're asked for the probability of a 1, a 3, or a 2. Okay? A 1, or 3, or a 2. Notice, and here's why I say that these things are set up. Notice that 1, 3, 2 is just the opposite of 6, 5, 4. Remember, all the faces of a die are 1, 2, 3, 4, 5, 6. So this grouping is really just the first 3, and this grouping is the second 3. And so the first 3 probability is just the opposite of the probability of the other part. So since we have 1/2 for one set, we find the complement of that, meaning subtract from 1. So 1 minus 1/2 is 1/2. So your first answer for this one is 1/2. Now the probability of obtaining a 1. Remember that this is what we were given. The probability of 4, 5, 6 was 1/2. The probability of 2, 4, 5 is 1/2. And the probability of 4 is 3/16. These were given. So we know that we calculated already 1, 2, 3 was 1/2. Remember, we subtracted from 1. Now part B is a little harder. We're looking for probability of 1. Note that the probability of 1 is the probability of 1, 2, or 3 minus the probability of 2 or 3. So just take away the 1 from this first group. Since we know the probability of 1, 2, and 3 is 1/2 from right here, and we know the probability of 2 and 3 can be found from the given information, because 2 and 3 is just the probability of 2, 3, 4. Wait a minute. Why do I have 2, 3, 4? Our original was here, 2, 3, 4. Okay, I typed this wrong. There we go. That's the problem. 2, 3, 4. I said 2, 4, 5 or something. 2, 3, 4 right here was what was given. So 2, 3 can be found from the fact that 2, 3, 4 is 1/2. Just take away the probability of the 4. So if I have 2, 3, 4, take away 4. That leaves me with the 2, 3. So that's the 1/2 minus 3/16 from here. Well, 1/2 is 8/16. Take away 3/16, and we get 5/16. So your second part of the problem is 5/16. Okay, that's part B. So your probability of 1 is 1, probability of 1, 2, 3, minus 2, 3. So 1, 2, 3 was up here as 1/2. 2, 3, we just calculated down to 5/16. So it's 1/2 minus 5/16. 1/2, remember, is 8/16. Take away 5/16 is 3/16. So that's the answer, part B. Okay? Now I'm going to do a different version of the curious die. And remember, if you just joined me, Okisha, then you can go back. I did another version of the curious die to start with. You can go back and look at that in the recording. So here a peculiar die has the following properties. The probability of rolling either a 6, a 3, or a 1 is 1/2, just as it is with an ordinary die. Moreover, the probability of rolling a 1, a 5, or a 2 is again 1/2. However, the probability of rolling a 1 is 3/8, not 1/6. So here's where the whole die is curious, is that one of the faces is weighted. So this time we're asked to find the probability of anything but a 1 and the probability of rolling anything but a 4. So first, the probability of rolling anything but a 1. The probability of 1 is 3/8 right here. So the complement, which means anything but 1, would be 1 minus that. So 1 minus 3/8 is 5/8. So that's the answer to the first part of the question. Now the second part, part B, to roll anything but a 4, this is harder. Always part B is harder. To roll anything but a 4 would be 1, 2, 3, 5, 6, all but 4. Notice that is 1, 3, 6 plus 2 and 5. Since these two events are mutually exclusive, we can just add their probabilities together once we find them. So our goal now is going to be to find these two probabilities. Remember that the probability of 1, 3, 6 was 1/2. Whoops, what did I do? The probability of 1, 2, 5 was 1/2, and the probability of 1 was 3/8. Okay, these were given. This was how the problem was written to begin with. Okay? Now to find the probability of 2, 5 is the same thing. We can take away the 1 from this second probability, 1, 2, 5. How often would I be having a video for extra help? Every couple of weeks when I have time, okay? Okisha, I will do these as often as possible and then make the recordings, and then I post the videos in the course. So I'm trying to create these for you and letting you join me as I do, basically. Okay? I would love to have you join me as often as possible. Okay, so 1, 2, 5, take away the 1 would be 1/2, take away 3/8. And so the probability of just the 2 and the 5 is 1/8. So since what we need is 1, 3, 6 plus 2, 5, the 1, 3, 6, you remember up here is 1/2. The 2, 5 is 1/8 from there. So 1/2 is 4/8 plus 1/8 makes 5/8. Okay? So there is the curious die.